So in this video we are going to be looking at the answer of this question. So now first let's read this question. Before that they have given some instructions. Now we have to answer all questions, and the time allowed, since this is a 2 credit course, we will be given 2 hours to answer 4 questions. Now we will look at the first question. Before that they have given some instructions. Statistical tables are attached to this question paper. Basically for this calculation we will require F table. Now this is attached, and then we will calculate F value by constructing the Anova table, and then with the table value, with the table F value, we will compare it to conclude whether there is any difference between the means of the treatments, right? And then calculators, definitely without calculators we cannot do these questions. And then use alpha is equal to 0.05, which means we have to use 95% confidence level. Okay, right. Now in an experiment to study the effect of the amount of baking powder in a biscuit dough upon the rise height of the biscuit, 4 levels of baking powder were used and 4 replicate biscuits were made with each level in the random order. The results are shown in the table below. Right now, this is usually CRD design, right? So in the A part they have asked to name the design of this experiment. So in order to identify which design we are going to select for performing this experiment, now we have to identify the population, and we have to identify the sample, we have to identify which are the treatments, we have to identify the treatments unit and all, right? Now if you carefully read this paragraph, then they are telling now we are going to deal with biscuits, right? So biscuits and the rise of height biscuit, 4 levels of baking powder, right? Now we are going to cook biscuits using 4 different kinds of baking powders, right? So now these baking powders are called treatments, right? Treatments. So here we have number of treatments. Number of treatments is equal to 4, right? So we have 4 treatments here in this question, and 4 replicate. For each type of treatment we have 4 replicates, right? So 4 into replicates is equal to 4. So 4 times 4 is equal to 16 biscuits, right? So we are going to perform this experiment on 16 biscuits, right? So 16 biscuits. Now these biscuits are what? Experimental units. Experimental units, right? Okay, now you see this. Give the statistical model. Okay, 4 replicates biscuits were made with each level of random order. The results are shown in the table below. Now here this is 0.5 TSB, 0.25 TSB, 0.5 TSB, 0.75 TSB and 1 TSB. So what it means is, now this is treatment 1, this is treatment 2, this is treatment 3, this is treatment 4, right? So now we are using these 4 levels of baking powder. 4 levels of baking powder means the same baking powder is used, right? So baking powder is used, but here we are using different tablespoon, right? So TSP stands for tablespoon. Now we use 1/4 of tablespoon, right? So which means 1/4 of a tablespoon. Now this is half tablespoon, this is 3/4 tablespoon, and if you use 1 tablespoon. Now what will happen to the height of the if you use baking powder to the dough, that will happen while cooking, it will rise, right? So the biscuit will rise. So now we are measuring the height, right? So if this is biscuit, now let's say we have just taken a small handful of dough, and we have just kneaded it to make it biscuit. Then we cook it, right? So what will happen? It will rise. Now we have measured the distance or the height of this rise, right? So if you use now these are the observations, right? So if you use more amount of tablespoon, then it will be, the height will be high. That's why this is 11.4, this is 27.8, this is 47, and this is 61, right? So in this direction, the amount of tablespoon that we use in baking powder increases. So what will happen? The height of the biscuit also will increase, right? So give the statistical model equation describing all the notations, right? So now since this is a complete randomized design, now we are going to use this. Now this is for the first one, the answer is CRD, okay? And here yi is equal to mu plus tau I plus epsilon I, okay? So now yi is equal to, yi represents ith observation. So ith treatment observation, or we can tell at ith treatment observation, right? Ith treatment observation. Now if it is y1, for y1 we have 4 observations, right? So y1, now if you mention this j also as replicate, then it will become yij, right? So yij means ith treatment and jth replicate, okay, jth replicate. So we can modify this equation as yij, right? So you can write, you don't need to mention this, ith treatment and jth replicate observation, okay, observation or corresponding to ith treatment and jth or replicate, whatever you can write. Then mu is equal to grand mean, okay, and tau I is equal to, here only the treatments are the main effect, because replicates don't have any variation, because we are taking the same amount of biscuit or the same kind of biscuit, right? So tau I is equal to treatment effect, and this is error term. So for error term also we can use ij, right? So error term for ith treatment and jth observation, right? So this is the statistical model that we are going to use here. And now what is the experimental unit? Definitely that is biscuit, right? So we are using biscuit here. For example, if I want to make you clearly understand about this treatment units, now if you are doing a research with 100 people, now we have to calculate the average marks of these 100 people. Now from this 100 people we take 20 people, right? So the people themselves are called experimental units, and if we are analyzing their marks, then the data will be their marks, right? Okay, now here estimate the treatment effects. Now they are asking us to estimate the treatment effects, right? So how we can estimate the treatment effect is, first we have to calculate the treatment total, right? So this is y1 dot, this is y1 dot, this is y2 dot, right? So y1 dot means first treatment and first treatment total. So in that scenario we have to add all these values, right? So add these all values. This is y3 head plus this is y4 head, okay, right? Now we will calculate it. Okay, now I have just calculated the totals of each treatment. Now let me just take some assumptions, right? So A, I am going to take number of treatments, okay, number of treatments, and B, I am going to take number of replicates, right? Number of replicates in each treatment, right? In each treatment. Now I am going to find out the estimate the treatment effect, right? So that is SS treatment, right? SS treatment is equal to summation yi dot square divided by b, right? B minus correction factor, that is y grain total, y double dot divided by a into b, right? So now if I substitute these values, now here 43.2 square plus 109.8 square plus 187.4 square plus 250.9 square divided by, since we have the same number of observations in each treatment, then we can divide the entire value by 4, right? Since we have 4 here, right? Here also 4, here also 4. Okay, but if we have allocated different experimental units for different number of experimental units for each treatment, then we have to divide the square of the treatment total by their respective number of replicates, right? So you should know that, right? Sometimes in the examinations they might ask. For example, in the treatment we have 6 observation, in the treatment 1 we have 6 observation, and treatment 2 7 observation, treatment 3 8 observation. Means now you have to first calculate the treatment 1 total n square divided by 6 plus. Likewise you have to perform it, right? Okay, I'm just telling this point. Sometimes you might know this. Okay. Minus now grain total, minus grain total, this the total of the treatment total will be the grain total, right? So 43.2 plus 43.2 plus 109.8 plus 187.4 plus 250.9 is equal to 591.3. So grain total y double dot is equal to 591.3. Then you can separately calculate correction factor, so that if you want to, since this is CRD, we can easily find this out, right? So, okay. Correction factor is equal to y double dot whole square divided by AB. Now this is equal to the total 591.3 whole square divided by 4 into 4, right? So divided by 60 gives me 21,852,852.2366063. Check your answers, and if I have done anything wrong in the calculation, you can let me know in the comment section, right? So now here correction factor, this value 21,852.23063. okay. Now we will just calculate this. Let me calculate 43.2 square plus 109.8 square plus 187.4 square plus 250.9 square is equal to this, divided by 4 is equal to this, minus this value 852.230000064. So the answer is 6145.73186. okay. Right, now this is SS treatment. Then we are supposed to calculate SS total also, right? So let me write down this SS treatment here, so that SS treatment is equal to 6145.73186. okay. Right, now I can erase this. Okay, now we will move to the next question. So perform the analysis of variance to test the hypothesis of number of treatment effect and state your conclusion also, right? So this, for this part they have allocated 14 marks, so it involves a lot of calculations, right? So perform the analysis of variance. So in order to construct the Anova table, we will need to find out the SS total also, right? So SS total is equal to summation yij square minus correction factor. That's all. So now we have to individually we have to square all the observations and then take the summation, right? So let me do it. Let me pause the video here and do it. Okay, so I have now calculated the this value. So that is 11.4 square plus 11.0 square plus up to 63.0 square plus 63.9 square minus correction factor, right? So that is 21,852.2306, that one. Okay. Right. Now if I calculate it, now I don't know whether this is correct, correct or not. Sometimes I might have done some mistakes. So you better let me know if I have done it correctly or not. Okay. So 28011.45 minus 21852.3, that value, right? So now minus correction factor 21852.852.2306063. So the answer is 6159.21937. Okay. So now we can calculate, construct this Anova table. SS total is equal to 6159.21937. Okay, right. Now we will try to construct this Anova table. So this is a one-way Anova table. So the sources of variation, right? So sources of variation, we have treatment, error, and total variation. Okay, total. Now degrees of freedom. Now 4 minus 1, a minus 1, right? So a minus 1, 3. Here also 16 minus 1, right? 16 minus 1, 15. So error term will be this minus this, 12. Okay. Now sum of squares, right? So we have already calculated this treatment one, that is 6145.732. okay, I'm just rounding off to this third decimal, and again here total is 6159.219. okay, right. Now error term is 6159 minus 0.219 minus 6145.732, 13.487, right? So that is the value. And here we can calculate MS also. So MS means this divided by this, right? So SS treatment divided by degrees of freedom, the treatment degrees of freedom, 6145, okay, 45.732 divided by 3 is equal to 2048.5773. Now this divided by this, 13.487 divided by 12, that is equal to 1.12. So now we can calculate this F table, this divided by this. So what is the value? 2048.5773 divided by 1.12 equals 1829.08. okay, right. Now F calculated is equal to, always it should be greater than, then we can conclude. Okay, now we will calculate this F table. F table is equal to F alpha by 2, this one, (3, 12). So here we can go to the F table, upper value 3, lower value 12, right? So upper value 3, lower value 12. So here the F table is given. So here the upper value 3 and lower value 12. So this is the value 3.49. Okay, 3.49. So this is 3.49. So definitely it should be greater than f calculated. So we reject h naught. So we can write down h naught. All treatments have the same yield or have the same mean height, right? So mean height, and but here h1 is equal to at least one pair of treatment have has the different mean height when compared to others, right? This is what we have to write down. So that is the conclusion, right? So and then we can now you are supposed to write down this hypothesis before comparing these f values, and then you have to write this, and then you can at 95% confidence level you can statistically conclude that at least one pair is different from the others, right? Okay, so that's all. And I don't know if this answer is correct, because the theory part and the procedure is correct, but unless I have not made any calculation error, right? So you better drop a comment mentioning if I have done any calculation error. So we will meet in another video. Bye.